Hi everyone. You want to come up? Um, Jamie, how are you doing?
Hiya, Katrina. How are you?
Good, good.
Did you get?
But,
I heard the end of the chat yesterday. Had to fill in myself with the rest of it. It went on for quite a while actually after I had to go.
oh, really? Yeah, we
Yeah,
went. We went for a little bit. Yeah, I mean it was
yeah,
like a very broad discussion,
it was.
but
Do you know, one thing I thought was hilarious was do you remember it was was it last week or something? And I'd only just started to talk to you guys a couple of times, and in the room with Dennis, we actually had talked about the base pairs for the genes, and we totally talked about the coalexal lizard and the amount of base pairs in a tree, and it all came up yesterday in the talk, which I thought was really fun.
yeah,
Sorry, I
right.
missed it.
Uh, no, it's it's fun on the weekend to have like more general discussions. I think it's kind of fun. I think a bunch of our group members can make it, but the idea of this room is twofold. Of all the rooms, is twofold that we have at Science Society. One is, of course, explain what happened this week to our audience, to our club members. But the other thing is to generate a recording that I don't have to edit too much, because my idea is to make a summary version of all the guest speaker events we have throughout the week. A summarized version if people don't have time to listen for a long time to our very long kind of podcast. And I thought first of editing it, and then I thought, oh, it's just faster to make a room, summarize it, record it, and then post it as a podcast. So that's twofold the idea of having these rooms. It's just easier. And it's more fun also because we get to interact at the same time, and I don't sit by myself in front of the computer doing this. So, yeah.
Absolutely. If you need me just to kind of be quiet or you need me to fill in little gaps or whenever there's
Yeah,
something that
always fill in.
yeah.
Yeah, it's more fun if you fill in. So, yeah, so the first room we had was about exogeology with Dr. Ash Salamat. This was a really fun room. Um, I think we'll have a best speaker award. And I mean, this week in general, I'm not sure if we can ever replicate the week we had. This week was filled with amazing guest speakers. So, yeah, so Dr. Salamat, he um, he does different research. Usually, he does superconducting research, and he did some major advancement breakthroughs there. And he will talk about this end of May. I think it was 24th of May or so. He will come back. But this time, I invited him about his exogeology work and what he does, and this he funds by himself with his own funding that he generates through his small company he has. So um, because that's like his fun work. And so what they did is what they do is figuring out how different things like water would look like on other planets and other different conditions, and also look at all kinds of different properties of water, like what is water and what is a metal, was one of the very interesting discussions we had. So what they do is with a laser they heat under different types of pressure also um, water in this case, and find different H bond symmetries, transitions, and have very interesting observations also on the quantum level. And the interesting thing is that water at some point turns into almost like a metal and a superconductor. So it's a really interesting study. I recommend reading the paper. I pinned it to the room here, and also his superconducting work is really interesting. So I don't, Amy, if you have something to add, please go ahead. No, nothing. Yeah, he was a great guest speaker. So if you want to listen
Oh,
to, oh, go ahead.
sorry about that. Someone was pinging and I had to click the dismiss before it let me click on mute. um, yeah, there was also, remember, he mentioned the part about what was it now, the hydrogen atoms, and how they had to share the electrons to make it into metal or something like that, which was blowing my mind. Remember that?
Yeah, 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 exactly. So
Yeah, so he
it's
took it to, and all the stuff with salt as well, with sodium, and how it could conduct electricity, and how it could, because it become a metal. Am I remembering this correctly?
yeah, yeah. It's so the question was in general, what is a metal? Because just shiny and being have certain conductance properties is really not enough. So even that is not really established. It was a amazing discussion. So there is no fixed answer to what is a metal and a water, but it looks like under these conditions, and water becomes gets these metal-like properties, and also becomes like shiny like a metal. And
Yeah,
yeah, and also gives us insight how water could look like on different planets under different pressure and heat. So yeah, it's amazing.
absolutely fascinating talk. And anyone listening to this, if you do have time, absolutely highly recommend going back and listening to it. Absolutely.
Yeah, and he's totally fun also. And now we owe him a bunch of
Great.
beers. So,
It was a great talk at the end, yeah.
so yeah. So let me, if you want to say something, I'll just get the next link really quick.
Yeah, and his discussions on the possibilities about finding um, life on other planets, and even, what metal was, and it blows your mind. It was redefining what I was thinking of metals, um, and what can be used to conduct them, and yeah, highly recommending it. I'm trying to remember all the details, but I don't want to try and misquote them and then not do the man justice. But
Yeah.
incredible.
Yeah, and the thing is that water gets these superconductor properties under these different conditions, and yeah, he did really a major breakthrough for in superconducting materials, and that's like how he finances this fun job. So if you read about him, Ash Salamat, yeah, you will probably get the news about more about the superconductor work.
Okay,
So
we
and
haven't heard
that's
the
what he's
last of
going to, yeah, he's going to present that next time. He's coming end of May, so really looking forward to it. So on Tuesday we had then Dr. Lenz coming here. He Nathan Lenz. He's at the New York John Jay College, the New York City University. He is in forensics basically, but genetic forensics, and he also does evolutionary work, like human evolutionary work. So it's a very interesting combination, and he also wrote some books, and publishes also like in Psychology Today, and he has the Human Evolution blog, and he looked at the evolution of the de novo human specific microRNA genes on chromosome 21. So he found basically genes that turn into families of microRNA genes that are only found in humans. And this this is quite interesting work from the technique, how he sequences and finds these genes, but then also for the evolutionary, like what makes us human type of work. So it was a relatively short room, but I think it was pretty interesting to go into, to go into his research.
And he was going into his enthusiasm for the untapped potential he believed that mRNA had. Yeah, and he was saying how this could be indicating that the mRNA could actually affect and rewrite and interact with the actual RNA, didn't he?
Yes, yeah, definitely. And
Hmm.
I agree totally with him. That's why I think his work is so knowing about these different microRNA genes that produce this different microRNAs will, I think, help us in many ways. And there's a lot of other labs looking into that, to find ways to not just maybe find the medicine that like treats the symptoms, but go really into the underlying condition that is probably like also a gene expression problem and how microRNAs are being expressed. So yeah, I completely agree with him. So
Mm.
yeah, but
And
this
it
is a
has
nice, yeah, this is a nice also basic science approach example that can lead then into translational application. So I think this is a really nice example of that.
definitely his talk was largely bringing like awareness about the potential of this, but he did emphasize just how much more there is still to discover, and the potential for what it could mean could be mind blowing. So it's definitely worth anyone listening to this to keep an eye for anything that he might come out with in the future, because we're only just going to hear more from this. He said there's still so much to find out, so many questions.
Yeah, and he promised also to come back. Yeah, but he had a lot of fun. He wrote in an email he was surprisingly enjoying this because most of our speakers, except very few, are new to Clubhouse, and they are very weird out in the beginning. Audio only, and I can't go through the slides how I'm used to do. Like, people are very hesitant. Like, most people are very hesitant before they come, and then after it happens, they usually write, "Oh, this was so much fun." Like, even yesterday, Marco Fazzini, same thing. I was so critical about this because we had a bunch of phone calls before. I was very nervous about it and hesitant. And now I had so much fun. Let's keep in touch on Clubhouse, he said. So
He was incredibly positive about the whole thing. He was brilliant. Yeah, but we will totally get to Marco in a minute, right? What is it Wednesday we're on then?
yeah, so Wednesday, let me get the link for Wednesday.
There we go.
Sorry
So
that
for
I'm taking
so
a
for
while to.
anyone looking to challenge themselves, try and figure out mRNA. It's one of those parts of biology that um, that you just uh, every time you think you know biology, you don't.
Hey,
That's just a good rule.
Denise is here. Hi, how are you?
Hey,
Hi, Kevin.
Denise.
Hi,
Hi.
Amy. Hi, everyone.
We
What did I
are
miss? What did we cover already?
Monday and Tuesday. So Dr. Salamat and Lens. But we can still, like, there's no reason for you to comment. Like, we had an amazing week. Like, we had like really outstanding research. So yeah, please give your comments about Dr. Salamat, the exogeology room, and then Lens, the human evolution genetics room.
Let me get some notes because there has been so much happening that it's hard to keep track of everything without the notes. Give me a moment. We can come back to. I mean, we could just move forward and then I can integrate those back in later.
Oh, actually, I'm on the wrong day. I missed the carbon negative production. So I'm sorry, guys. I have to go and share first another link. I'm really sorry. It's
No worries.
That's
I'm
no problem. A
actually
lot happened this week. So much.
so actually we had the carbon negative production of acetone isopropanol. Uh, sh- this was one of the few guest speakers we had. We had one before that is actually working for a company and not in academia. And her work is really, I mean, from a biology, engineering, cell engineering perspective, it's amazing work. And also, then the whole production line and scaling up this technology to actually use it in the real world. And capture how much did she say they already captured?
On the order of, I think the number was 160 million what units? Let me see if I wrote that down.
Yeah, it's amazing. So what they
It's a
do,
very large volume, yeah.
they collaborate with farmers around the world, and different, um, yeah, they are scaling up quite fast to collaborate with different companies, farmers, to basically turn their waste basically into acetone and isopropanol by gas fermentation. And they are doing it on an industrial scale. I think they fueled a plane with this that flew for from, where was it, from Asia to the
I think
US?
it was Miami to Heathrow or Gatwick, somewhere in the UK.
Oh, okay, okay. But it was a transcontinental flight,
Or
which
Orlando to
is really
Gatwick, yeah. Transocean. That's far. I don't have the numbers, but it's not a short flight.
yeah. So
Would it
they basically made the fermentation process more efficient by engineering. So first screen all the genes that are participating in this fermentation process, um, of this microorganism and a Clostridium autoethanogenum. And so first they screened for the genes that are participating in this, and then they started optimizing basically the genome in a way that this process is more efficient, basically. And it's a huge, like, it was a huge effort. I mean, it's very labor intensive to do this stuff. And then they also engineered their process in a way to make it, like, to scale it up. So if you look at the paper, believe it's open source. If not, please let me know. I can send you the PDF, send you a link to my Google Drive, and then you can download it from there. Yeah, and then they scaled up the process so they can continuously doing this. The good thing about this fermentation process is that this is not a bioreactor that you have to constantly exchange. it's a continuous process. This can go on and on forever, almost. So it's really interesting. Yeah, Denise, Jamie, go ahead.
Would it be far-fetched to say that what she's working on could potentially be world-changing?
Yeah, I would agree.
Yeah, I would not disagree with that. My only it was really interesting to hear all the technical details, right? So they did like Katerina went over at a high level, but I'm going to get a little deeper on it. There were 4 of 13 genes that they knocked out in these organisms to get to higher outputs of the substance that they wanted. We didn't get into the genes that they knocked out, or maybe they didn't. I didn't catch it, but um, the source of the organisms that they were the Clostridium that they were knocking out was actually rabbit poop, which is which is an interesting fact. They had so I looked at the notes. It was 160,000 tons of CO2 that they were able to remove from being emitted in the during the process of production. Now, obviously, those are going to go right back into hydrocarbon fueled jets. I'm looking forward to the electric jets that are coming out, but in the meantime, this is definitely very exciting. They had um, 2 factories in China in 2018, and they're planning to bring an additional 5 online in 2022 in this year. And
Were these the one, Denny's, that was producing the ethanol? I remember she mentioned producing ethanol and that the factories could produce, was it for 90 days, but at a push they could do longer? Am I remembering that correctly?
I think so.
I
The
think it
ethanol
was
was
that.
with gas metabolism. This is a different mechanism.
Ah,
Yeah, so I think this is a continuous process, so it doesn't have that limiting factor of like 90 days.
And she said that
That's like good.
mm, yeah.
during that cycle, there's also downtime because you have to decontaminate the reactors. Versus with this process, you don't have to do that until there's some sort of failure in the process, and then at that point you might have to decontaminate the entire thing before you start the reaction up again. In fact, I'm it's hard to imagine that they wouldn't have to do that.
Yeah.
But that's in a outside of standard operating parameters situation, and then the equation changes.
And she went into
Yeah, I don't know, Denise, if you wanted to add something to Doc, like Ash's room or Dr. Len's human evolutionary room. Well, I'm looking for the next link to pin.
On the, did you say Dr. Salamat also?
Yeah, yeah.
Because that was
Hmm.
big. So that was a really interesting talk. Some of the takeaways that I had were that um, one something I wrote a note down said weak low in CO2. I don't. I really need to remember what that means. Um, but it was really interesting to look at the curves that were as part of his presentation. It was very interesting to find that there are 18 different phases of water. That's something I did not know before I was exposed to this work. And let's see what else.
And that we don't know what metal is, and that water can be a metal and be a superconductor. Those were
Cool.
the most key point. Like those are, I think, the most important key points. That
Yeah,
we
those are definitely on the list for sure.
met.
The other notion that was introduced that I had not been exposed to in a long time was the quadrilateral pole gravitational fields on different planets. I don't think we specified where that was. But yeah, like you can compress water so much that it has metallic properties. Like, think about that. Like, whoa.
I was trying to remember that fact a minute ago, Katerina, but it was out of my head. Wasn't that compression of something crazy like 300,000 times or something? Really,
Oh
really
yeah,
high?
yeah, yeah. Of course, but yeah, but still, that doing this to basic things like water makes us learn. Not that it happens like on our planet, but it could be another planet. But to know what properties things could have under very different conditions is it's pretty amazing.
Didn't he also say theoretically you could create like a bottle out of, was it CO2 or something? And if you put water in it, it would immediately turn it into carbonated water?
I think I do remember something like that.
Yeah.
I can't remember if it was CO2 he said, but he said you could take the substance and you could compress it to make it a bottle. So anytime you put normal water in it, it would like push push the carbonate in there and whatever the effect was, and it turned it into carbonated water just by being in the bottle. Which because I remember saying, I want one. Where can I get this?
Yeah.
Exactly. I'm
Yeah, he's
surprised
a
that's not a commercial product yet.
yeah. He's a great entertainer. Like he's a great scientist, like very amazing and very successful scientist, and at the same time a great entertainer. I think.
Definitely, great
The
guy.
Just to put some numbers on it, you were talking about the pressure, so I wrote it down. Earth's pressure is 3.3 atmospheres. The sun is 1 billion atmospheres,
Ooh,
and these calculations were taking place between 40 and 120 atmospheres. So these are pressures that are at least at the surface. A lot of these processes can happen in subsurfaces, even though the temperatures in the experiments were not super cool. They were about 80 Fahrenheit, which is about 27-ish Celsius, 300 Kelvin for people who like the Kelvin scale. I like the Kelvin scale, but I know that that's not everybody.
Yeah, and then on, if it's okay to move on to the next one with everyone,
Yeah, let's go.
we we had Dr. Sharon Moraine from the UK. She's a faculty member of science and engineering, but also psychology and sports science um, in Cambridge, UK. And I really like her because she's also a very broad scientist. Like she says, she's all over the place, and usually, maybe just I identify more with them. But yeah, she was presenting the work I posted on here as a link. But when you look at her profile, she has like she spans a very broad area of research, and yeah, she talked about how hoarding, the history of how hoarding became classified as its own disorder, which opened up funding and better research or scientific approach to the hoarding disorder. And she looked at comorbidity, or um, how likely it is for people that have ADHD to also have hoarding. And yeah, this paper talks about it. We talked more in general, also about mental health, but it's quite interesting. It's quite common for people that have ADHD disorders to also have hoarding disorder. And although most like the prevalence seemed to be higher in women than men, but it could just be that especially at the like the people that come to the doctor with hoarding are at a more advanced age, although they say they always had issues with collecting too much and not being able to throw things away, but when they actually go to the doctor it's quite late in their life, and usually more women come. But it could be just a social pressure type of thing, because at that age most men don't really clean up after themselves like traditionally, and women do. And then if a woman doesn't clean up her house, it's a way bigger pressure for them to do something about it if they have a messy place, basically. But it's not just a messy place. Hoarding is when it actually hinders you from having a regular life. Like your bathroom is so full you cannot use it anymore, your kitchen is so full of stuff that you can't use your kitchen anymore, you have infestation because of this, and you cannot have people, your family over anymore. So it's only then considered as a disorder if it hinders basically your everyday life, or if your quality of life suffers from it. So the prevalence seemed to be more in women, but we are not sure if it actually is. And it definitely looks like that it happens. The comorbidity of ADHD and hoarding seems to be, this paper shows that there seems to be a link. And then we talked about why that is, what could the underlying mechanisms be, if it could be linked to dopamine levels. Then the emotional part about it that she also looked into in her work, I think was interesting from a mechanism standpoint. To look into those questions, she collaborates with people that also work with animals. So I'm really looking forward to to the research that will maybe of her and her collaborators that will maybe explain more about those mechanisms. So yeah, if you have something to add, go ahead.
I missed that talk, so thanks for the summary. I was interested a little bit more in, so you said that they were comparing ADHD and then hoarding. Is that right?
Yeah, if
As
it
basically a precursor, perhaps maybe predictive in
yeah,
some capacity.
yeah, and the emotional aspect, yeah, exactly. And yeah, she says there's more females than males also in the study, because just not too many males go to the doctor with hoarding disorder.
So this is probably a question for her, but I'd be interested if you had an answer. Is there any correlation with hormonal cycles in the higher prevalence group?
Yeah, that's interesting, but she didn't look into that. Also, dopamine levels and things like that. She said this is one of the first studies that looks systematically into this, but yes, she's collaborating with different people to study this in animal models, like and what the factors could be, and what the maybe in the brain, maybe there's a mechanism that is responsible for both, for ADHD and hoarding would be interesting.
Should be interesting to see if they are ever opportune to run genome analysis or if there's any potential predisposition there, and perhaps you can um, use some methylation complex to modulate that gene expression. Yeah, interesting.
Yeah,
I'm afraid.
yeah, I think that's interesting. The interesting thing is ADHD and autism spectrum disorders are supposed to be more prevalent in male, but this is kind of also changing a little bit, those numbers. But in general, but then ADHD with hoarding together seems to be more prevalent in female. I think that's interesting, that points, I think, towards maybe a different mechanism that is eliciting, maybe it's a hormonal thing, but maybe it's a completely different mechanism that leads in women to ADHD if it's combined with hoarding, versus in males it could be a different mechanism that leads to ADHD, or just that factor combined maybe with hormonal changes. But they claim they always had hoarding issues, just people just at a later stage in their life go to the doctor. So yeah, it would be interesting to do a similar study like what the researcher that came here that talked about Alzheimer's or dementia in females that was linked to the FSH hormone. It would be interesting that if she would use a similar approach in mice, like to study this. I agree.
I'm afraid I missed that one actually as well. I do mean to go back and listen to it because it's really incredibly interesting. But even the thing you just said there, Katerina, about the definition of what made it like a proper problem, like a disorder, was that very wobbly line of when it's actually getting in the way of your actual home life. So nobody out there who loves to collect spoons or DVD box sets needs to be worrying that they might be afflicted with this yet. It's only strictly when something's like what debilitating to the point of home life, like you can't clean your house anymore or you can't go into your bath just like you said. That's very interesting. Like the line being drawn there. Given the indication, right, that like many people to some extent can, you might even call it sort of hoarding or just like, avid collectors, right? But as long as it's not interfering with them socially, um, that's what makes it the disorder. I think that's interesting psychologically.
Yeah, it's like with OCD and all these disorders. She gave a really great lecture. Like, she gave a really good introduction of the field in general. What makes basically a mental health disorder defined as an actual disorder that we all like. Of all these disorders, OCD and so on, we have kind of can all identify with aspects from them, right? But yeah, she explained what gets then defined as an actual disorder and so on. So it's a really good like lecture for the field, like to introduce the field also, I think.
Fantastic. I'm definitely looking forward to listening to that part because I definitely had questions about these metrics and sounds like they'll be answered rather easily.
So we are already like, I don't think we need to discuss the roundtable discussion about our news artificial creativity room. So now we are already at Dr. Marco Pettini, and this was another amazing room. Let me get the link really quick. Yeah, I'll post the bioarchive link so everyone can access it. And he's a physicist from Italy, Florence, and is a professor at the Center of Physics in Marseille and also at the Marseille University in Toulon. And he's a full professor of theoretical physics, and he did a lot of contributions in the field, and also wrote the textbook. His work was about the experimental evidence for long distance electrodynamic intermolecular forces. And yeah, so he gave a PowerPoint slide presentation. If people want to look at it, please reach out to me. I can share the link with you. And so he gave a very good general introduction of his field and why they asked the question. And basically, he explained to us the hypothesis or the predictions the model they basically support, that there is a dipole long range electrodynamic intermolecular force, but they have never been experimentally observed. And they discovered basically this completely new and unanticipated forces acting between biomolecules that could have a considerable impact on our understanding of the dynamics and functioning of the molecular machines at work in living organisms. So he used mostly microscopy to and you can look into the paper if you want to have a deep dive, or then Denise, maybe you want to go. So but he looked into protein electrodynamic intermolecular forces, and the interesting or the takeaway is that by showing these forces you kind of have now a model, or you kind of have this experimentally shown way of how proteins could interact with each other and maybe self-organize. This is what basically the beginning of showing this is this paper. He's on a basically on a big collaborative work funded by the EU that will now look into in showing this maybe in vivo, because right now they did this just on proteins and elicited they brought basically the macromolecules out of their equilibrium and saw them having equilibrium collective vibrations. And yeah, if we can show this dynamic in the living cell, this could explain how proteins and biomolecules could have self-organized and could still self-organize in the cell, because this is still not an answered question. How does stuff biological stuff in the cytoplasm in the cell organize itself? We don't know. Like, how does the DNA and all these organelles and all the stuff that is in the cytoplasm and turns into the cell, how does it organize? What is the force behind it? And this could be explained with it if we can experimentally show this in a living cell. So yeah, please go ahead.
It's all physics. We just haven't been able to understand it yet, I think. The most exciting part for me of that was to see the way that there were all sorts of questions that he had not considered yet and were exciting to him to hear, uh, coming from you and Serena. And it was really nice to see that level of harmonic resonance. Basically, it was a positive feedback loop in the best way possible.
It
Yeah,
was
and what I
exciting to
forgot
hear how. Sorry.
to mention really quick is that he also showed that with these forces he could show this clustering of proteins, and they did it first with numerical Monte Carlo computations, and then could experimentally show this. That's why we are saying that, this these forces could explain how proteins and other biomolecules could organize themselves.
I was just going to comment on it was exciting to hear how open he was to, like you said, Serena and everyone else's ideas, and how much, you felt he was so intelligent in covering something this complex, and yet he still was quite taken with other ideas and was open to them, and it showed such an incredible flexible mind, right? And his story came from, what was it, Katharina? He began with a chalkboard, and then moved like up to more complex stuff to the point he has his PhD students making his software for him, didn't he say?
Yeah, he
Yeah,
was.
he used to do it all himself, but he says now that I'm older, the students do it for him.
Yeah, yeah, I love that. I mean, that's like such a at every single level. That's a clever idea. Get his PhD students doing his software now. Yeah, quite a remarkable man all round. Yeah,
Absolutely, and very kind and very very open-minded. That's the part that I appreciate the most is the open-mindedness of him and everyone else who is sharing the conversation.
Yeah, and that was our week. It was a really wonderful week. I mean, I enjoyed it and I learned a lot. And yeah, I'm looking forward to the next week. So
so stay tuned. There's a lot to come.
he is a researcher.
Yeah, we got to recap because the signal dropped on your side. We lost you. We lost you at basically the beginning of the preview for the coming week. And now the mic is off. Okay, these are typical manifestations of connectivity issues.
Can you hear me now?
Keep going.
You're back.
Testing,
Yeah.
testing.
Can you hear me now? I was
Yes.
also
Okay.
talking. So,
Let's start from the beginning of preview for next week.
okay, cool. Let's start with that. So, Dr. Fu from UC San Francisco, she's a sleep researcher, many years, I think over 20 years, she said. And she published recently a paper about elite sleeper genes that are found in some families where you don't need actually a lot of sleep, but the quality of sleep is so good that it protects from cognition, aging-related cognition issues. So, and they have also they are less prone to have mental health disorders. So, yeah, this will be a really interesting topic. Then we will have the team from South Korea, Dr. Jim and et al., who will talk about quantum charging to shorten EV charging. So it's a great engineering team that will come to present on Tuesday. Then on Wednesday, we'll have Dr. Bonat, potential supplement for longer human lifespan. He works with C. elegans, and it was a recent published paper that was in the news, and it will be really interesting. Then Dr. Van Zundert, it's in the morning at 9:30 a.m. She will talk about her ALS research that also was published, and she found a specific excess of neurotoxin that is associated with ALS. We've been struggling for many, many years with, to figure out what triggers ALS. So I think this study is really important. And then we'll have on Friday the ex utero mouse embryogenesis with Dr. Alejandro Castrejon. And so he will present about basically artificial womb research. And he is joining us from Israel, so he will present at 1 p.m. EST. So it will be another exciting week, and I'm really looking forward to it.
As am I. A lot of interesting stuff coming up.
I'm certainly looking forward to the week ahead.
Yeah. Okay. Thank you, everyone, for coming, being part of the weekly recap recording. And yeah, have a great rest of your Sunday. And I'm looking forward to seeing you all again tomorrow. It's already Monday. So, yeah. Bye.
Take care, everybody.
Ciao.
Ciao. 3, 2, 1. Bye.